All right, we're going to be going over sketching an example. This is just an example that's going to be after the note card 42. So let's go and get started. So it's going to be asking us to sketch this graph. But before we sketch it, it's asking us some preliminary questions before we get started on that, okay? So first it says, find the critical points in extrema. Okay, so if you notice here, in order for us to find the extrema, we need to take the derivative. But I don't want to use a quotient rule, so I'm going to go ahead and distribute the negative, and I'm going to go ahead and divide each one by 3. I'm going to put negative x cubed divided by 3 plus, and I'm going to put x because 3 divided by 3 is 1, and then minus 2/3. Okay, so I'm going to take the derivative from that. So it's going to be negative 2x squared, I'm sorry, negative x squared plus 1. So I bring the 3 to the front, and the 3 simplify, and then the derivative of this is 1. Okay, so I'm going to go ahead and figure out when is this 0 and when is it undefined? When does it does not exist? So if you notice here, it's a polynomial, so this is never true. So when we go ahead and solve for x here, we get x squared is equal to 1, and then we get x is equal to plus or minus 1 when we take the square root, okay? So these are our critical values, and we're going to go ahead and create a number line, and this top portion is going to represent y prime, this bottom was going to be representing the original function. So let's go ahead and test some values and plug it into y prime. So let's plug in negative 2, okay? So negative 2 squared is 4, but then there's also a negative sign in front, so it's negative 4 plus 1 is negative 3, which means it's less than 0. So that means it's going to be negative here, and it's going to be decreasing. Let's plug in y prime of 0. Let's test a value in here. So we plug it in here, we get a 1, which is greater than 0. So here we're going to get positive, we're going to be increasing. And on this portion here, we can go ahead and plug in a y prime of 2. Okay, it's going to be very similar to this one. So 2 squared is 4, and then the negative that's in front plus 1 is going to be less than 0. So it's going to be negative, and it's going to be increasing. Okay, so that's the points in which it's increasing and decreasing. Now we can determine the max and mins. So here I know I have a min because it's going down to up. So I'm going to figure out what is the specific y value there. So I'm going to go ahead and plug in negative 1 into my original. Okay, I'm going to plug it in this top one because it seems a lot easier to plug in. So negative 1 cubed is negative 1. And negative 1 times negative 3 is a positive 3 plus 2. And there's a negative in front divided by 3. Okay, so here this becomes a negative 2. Negative 1 plus 3 is negative, it's a positive 2. Okay, plus 2 is 4. And we get a negative 4/3. Okay, so I know my minimum. So min is negative 4/3 at x equals negative 1. Okay, let's go ahead and determine our max. So I'm going to plug in 0. And I'm sorry, negative 1. I plugged in already, so I'm going to plug in 1. Plug in 1 in here, I get negative times 1 minus 3 plus 2 over 3. So 1 minus 3 is negative 2 plus 2 is 0, and 0 divided by 3 is 0. I'm going to put my max is 0 at x equals 1. Okay, so here I have, sorry about that, you couldn't see it, but here I wrote max is 0 at x equals 1, and here min is negative 4/3 at x equals negative 1. Okay, so the next portion here, it's asking for when it's increasing, decreasing. Since I did the work above here, I put f is increasing at when x is between negative 1 and 1. Okay, let me turn the light real quick. Okay, and the reason being is because f prime of x is greater than 0. Okay, f is decreasing at when x is less than negative 1 and when x is greater than 1 because f prime of x is less than 0. Okay, all right, so here we're going to find the points of inflection. Okay, the points of inflection requires us to take the second derivative. Okay, in this case we're actually using y's, so I should have put y's up here. That's okay, I'll put y double prime. So that means I'm going to take the derivative of this portion here. That's the first, so take it again, that's the second. Be negative 2x. So I'm going to figure out when that's 0 and when that's d and e. Okay, that'll give us our possible points of inflection, P PPOIs. So here when I solve for x, I get 0, and then I create my number line, this top portion being y double prime, this is y. Okay, let's go ahead and test some values. So y double prime of -1. So y double prime of -1, if I plug in a negative times a negative, it becomes a positive, makes it greater than 0, so plus, and it's concave up. Y double prime of 1 makes it a negative, so it's a negative. That means this is this is negative, and that means it's concave down. Okay, so that means we have a point of inflection. So y has a point of inflection at x. Let me give you the point itself. Point of inflection, we have x equals 0, and when I plug in 0 into the original, let's see what we get. We're going to get -2/3 because this cancels out, this becomes 0, and we distribute the negative to the 2, that becomes -2/3. And then my justification, because f double prime changes sign, right? That's my justification. All right, this last portion, we can just use the number line that we have up here. So we know that y is concave up because actually y is concave up on x less than 0 because y double prime is greater than 0 at that spot. Okay, y is concave down on x greater than 0 because y double prime is less than 0. Okay, and on the next video, we're going to go ahead and graph. It says here, sketch the graph of y without a calculator, and we'll go ahead and do that on the next video. Okay.